Hello everyone, welcome to DevOps for your family. Today we are going to see what is the use case of uh, S3 backend. So if you see my code, we are using the backend as a S3 and we are creating a bucket and this is the key name and I created this metadata for the bucket is ES1, ES1. Okay. So what is the important of creating this S3 as a backend? So this is just to avoid the single point of failure. Also, we are ensure that it is useful to collaborate with all our team. So if I have the backend or the remote state or the Terraform state in my local, I cannot able to it may be a worst case that could be a scenario I'll be losing chances of losing my Terraform TF state code, that is the Terraform backend which we configured if we configured in the local. Okay, so also I cannot able to collaborate in a DevOps era because I need to collaborate with my team to maintain the state of the AWS resources. Okay, here before we jump into creating VPC, subnet, and security groups and the Jenkins server, we need to just go from the basics. So how we are going to create the S3 remote storage so that it will helpful for us to avoid such scenario which we discussed before. So I'm using a module, the Terraform module. I'm interested to create this bucket is called Terraform AWS module S3 bucket, and this is the module is a keyword and this is the module name I have just mentioned here, and this is the bucket name, this is the tag name. I just created a name with the bucket name also created by the Terraform just for other reference. This is the normal way of creating the AWS resources, AWS S3 bucket, and this is the example. I'm just put this is the reference name by the Terraform. This is the actual bucket name. Okay, and also maybe I can just put the environment name here, or I can say own, yeah, I can put environment, and I will just import this as a dev. Okay, so this bucket is used for development. That's what the intention to create the environment. Okay, so now in order to create this one, also in some cases we need to get the output of this resources that will be used by the other model which we are going to see in our next upcoming videos. So here I'll be using the output keyword, and this is just a name of the output what we have to define here. Maybe this now should not match with this one. This is our reference name we can create here. So here we have the output and this is the value. So how I'm getting the value? For the value, I need to mention the module which I created with AWS S3, and this is the S3 bucket ARN. There is a lot many attributes that we can able to get the output of the attribute while we creating the resources in Terraform in specific to AWS. Okay, so now what is this module.aops S3 bucket? If you go to my S3, I have defined this module keyword, and this is the bucket module name, right? So I just need to refer this module and the key name that will be followed by the exact output. So if you go to Google and just search for this Terraform AWS S3 module, which I defined here for creating the bucket, go here S3, this is the same Terraform AWS S3 bucket name, this is the module, and here we can able to see input, resources, output, and complete example. So if I just open this output, in the output we can able to get all the output what specified here. So first I'm just getting the S3 bucket ARN. So by the way, what is the ARN? ARN is the Amazon resource name. Every resource in the AWS that will be created with a name, so it's called AWS ARN. That will be referred by internally by the AWS also. So if I just come here in the output session, I'll just getting the S3 bucket ARN, that is the resource name. Also, I'm just interested in getting the bucket ID and the bucket region where it deployed. Okay, so if you see, this is the keyword, and I just referring here with the same name what we are getting from here. So this is the bucket region and also bucket ID. And here there is a confusion. Someone may ask, this should be the same as here. This is not the case. We can get anything here. For the sake of understanding, I just put, or I can just maintaining the same output near output reference which we are referring in the module. Okay, now we'll get into the action. If you see, I have created a shell script that will help us to deploy the resources, because I don't want to just run Terraform plan, Terraform init, Terraform apply everything manually, right? So it will be a a manual kind of a thing. We need to, every time we need to apply this one. Before that one, we need to understand Terraform. It's a separate entity that we are leveraging to create the resource in AWS. So Terraform should authenticate to AWS in order to create the resources in AWS cloud, right? For that, we need to create, I have a readme.md file. So the prerequisite, we need to have AWS account and we need to have IAM user that we need to create with the access key and secret key. And once you create that one, let me show you that one, by the way. And we need to install the Terraform. Okay, so if you go to any of the this one, so I'm going to create this in the resources in mobile. So if I just search for keypads, or maybe not a keypads, I'm just going into the IAM. If you go to the IAM, the user I'm using for this one to deploy the resources, it's called AOps. If you go here, if you see, there will be a security credential. So this is a security credential. By the way, I have enabled the MFA for the authentication, and there is a security credential I have already downloaded. By the way, if you want to create a new one, we can able to create two access key and secret key, maybe yeah. So just use any of this one. I'm just using command line, and next understand. So if you go this one, it will ask us to, because I don't want to get any trouble for this one. Probably what I will do, I will go to this EKS, and maybe I will create for one security credential for the sake of demo. Okay, so here I'll just, it's commanding we'll be using this one. So okay, EKSCTL demo user. This is just for reference. So once we have this one, this will ask us to get the access key and secret key. This is very sensitive information, so you have to keep this very sensitive. We are not supposed to disclose this one once it download. Okay, so we have to keep with us, because if we are not downloaded this one, we won't get any option to view this again. Once we miss this option, we need to create a new one. So after this one, okay, maybe we have just created access key and secret key, but by the way, we need to assign the permission, right? I just assign this user for administrator access, since this is a demo. But in production scenario, you need to ensure that the permission should be kind of RBAC. So what is the RBAC we need to use for the user to deploy? So that we need to ensure, right? So yeah, so now this, once we create the access key and secret key, we need to um, create a profile. By default, there will be a profile called default. So if you want to have any custom profile, so if you see, I have configured this profile name as AOps. So you can able to see this one, right? And if you want to just create one more profile with the name of example, so I can put OPSFORU. By the way, my YouTube channel name I'm just creating like a profile DevOps for you. So it will ask for the access key, secret key, and this is the metadata default region, and it will output format JSON or whatever it may be. Yeah, just press enter, it will take the default value. Once it create, if you have the access key and secret key, it will create the profile. So since I'm using the git bash in this Visual Studio Code, I need to like export this profile every time I'm running the Terraform init or Terraform plan, any command, in order to just uh, if I close this profile, by the way. Okay, so what I'm doing here, I'm just creating a like a shell script. So here I just define the to get visibility on the Terraform run various commands we are running, right? Terraform validate, format, init, plan, and apply. I'm just maintaining a color code for to differentiate that one. So after that, you see I'm just exporting the profile, and I'm just going with the Terraform validate and Terraform FMT to format the Terraform code. And here if you see Terraform FMT will format the files which is in the same folder. If you want to have the folder outside of our code, then you need to use this recursive, so it will useful for you to just recursively like format all the code which is out of the current folder. And also I'm running a Terraform init, Terraform plan, and Terraform apply. Now let us apply or run the shell script. So if I just simply run this shell script, it will prompt and it will go through the sequence, like it will export the profile, and it will validate the command, and it will go for the format, then followed by initialization of the Terraform, and followed by the plan, and the last step it will go and apply the changes, and it will prompt us to approve the deployment before it get deployed, right? I'm just running this shell script, so it will go through the code. What we are seeing here is running Terraform validate, right? That will separate for each and every code. For the Terraform validate format, it took blue color, and again for the initialization it took yellow color. This is just kind of some advanced thing, not advanced thing, just to separate the running script which I just want to understand while I'm running. Okay, so now this has created a plan. Now it's going to apply. So during the apply, once it applied, it will tell us the plan, like what the resource is going to create. If you see here, this is going to use in the backend for creating the S3 bucket, and this is just a reference name that is in the Terraform module. Actual bucket name is AWS bucket 05 October 2024. This is the bucket name I'm creating today, so I'm just inputting this as today's name date, and this will be just creating the tags while creating. This is for a reference, and followed by the S3 bucket public access this resource, and this will be blocking all the public ACL and the policies. It's applying the policy. So if I just run this click yes, it is going to create. Before that, I just want to show you what are the existing bucket available. So if you see, this is the Jenkins which I am using for my Jenkins CI/CD pipeline, and this is for our demo which I'm going to show you in a later videos. And this is a sample bucket, right? So I'm just going to apply this one. What is the expected output now? It's going to create a bucket, and it will apply the policy, and it will give us the output which we define in the output.tf. Yeah, you see, right? So it has added two resources, and this has given the output of the ARN. This is the bucket ARN, and this is the bucket ID, by the way, and this is the metadata where the bucket has created, right? And if I go to the S3 bucket resource here, if I click for the bucket, you can able to just reference this page, and you can able to see a ops bucket and with the today's date. Yeah, so and also we have the output here. So this is more important before we jump into all the resource creation in AWS, the VPC and subnet everything. So I thought of just explaining this so everyone can understand the importance of saving the Terraform state file in remote. That will give us more very safe environment, so that will avoid the single point of failure, and also it help us to collaborate between our team. Thanks guys, thanks for watching. And in our upcoming demo, the plan is to just create a module for, I have created a module, by the way. I will go through each step by step. The skeleton of this module is just, we are having a main.tf, that is a child child object, that will be a module that will be calling our root module. If you see here, I'm maintaining the same thing. Provider is AWS, and I will be going to create my resources or deploy my resources in AP South 1, and the profile I'm using here is AOps. So I'm maintaining the same approach. If you see the same shell script, that's going to help us to run all the interactive command which we don't want to run. This will take care of all the init and validate, format, plan, and apply commands, right? And the backend I have mentioning, because I have already created this using the S3 module. The bucket name is AOps Terraform from Terraform bucket, and the key is AOps. Inside this folder, it will create the TF state file, and this is the region. Okay, and DynamoDB I'm not going to create because it will incur some charges. So what is this? This will help us to log the bucket. It will be allow only one changes at a time. This is the use of this DynamoDB table. And this is the main file, main child module, that will be calling to our network security group and EC2. And this is the backend. We are storing all our backend terraform.tf state file. And if you see, this is the module. I have created a EC2 module, network, and security group module. So I'll be walk you through with all this code in our upcoming demo. And so that by creating this one, we'll be creating a network for VPC subnet, then followed by the security group and EC2. In the EC2, we are going to install maybe more than 7 to 8 application without any manual intervention. So if you have my readme.file, we are going to install unzip, git, java, jenkins, terraform, kubectl, EKS, helm, and some network related application. You see, this is the very useful to us, because we are, if you want to install this manually, deploying all these things manually, that will take more time, and also there might be a chance we'll be having some manual error. So by using this IAC concept, that is the infrastructure as a code concept, we can avoid the failures, or not the failures, we can avoid the manual error, as well as the team collaboration and the fast deployment of our resources, and we can be able to versionally control all our resources what we are deploying. So we can visualize or revisit what we have done, what we have deployed. So this will give more visibility to us. Yeah, thank you guys. We'll see in our next demo. Thanks for watching. Please subscribe and share to your friends if you really like the command. Okay, thanks for watching.